Hello, everyone. Welcome to our Rhino Modeling Practical course. This is the first lesson, and today we're diving into creating a curved landscape pavilion. Let's get started on this exciting journey. From modeling skills to design skills. I'm Architect Smith. I hope you'll find something valuable here. So, welcome to my channel, and I look forward to seeing you in more videos. Please install the software before the class begins. Now for the exciting part, let's open Rhino. As the software is loading, you'll see an interface that displays the models we've created previously. You can simply click on any of them to open, which saves us the trouble of searching through files. Of course, if you're using Rhino for the first time, there won't be any file records here, so no action is needed. Rhino will automatically create a blank file for you. What we're looking at now is the Rhino workspace. You'll notice that the Rhino interface is made up of several parts. The four areas in the middle are the viewports. By double-clicking the small button in the upper right corner of each viewport, you can switch directly to that specific view. These viewports are where we'll be doing most of our modeling work in the future. Next, on the left side, you'll see a collection of tools. That's our toolbar. Most of the tools we'll be using are listed here. Additionally, some tools will produce different effects when you click with the left mouse button versus the right mouse button. Also, some tools have a small triangle in the lower right corner. When you click on it, it will reveal more related tools. If you have experience using Photoshop, this should look familiar to you. The top section is also a toolbar. This toolbar categorizes all of Rhino's functions based on their features. Any plugins that you install in the future will also appear here. Of course, don't be intimidated by all these tools. Many of them we won't use at all. Pressing the middle mouse button brings up a customizable toolbar. You can place the tools you frequently use here and easily access them whenever needed. Just get used to using it regularly. Of course, since this is your first time opening Rhino, there are probably only a few tools here. In the future, I'll help you all learn how to customize your own toolbar. On the right side, you'll find a panel bar. This area displays various attributes of the model and the file. For instance, it's showing the model's position and some properties related to the viewport. At the very top is the menu bar. We'll rarely use it because its functions mostly overlap with those of the toolbars below. Below the menu bar is the command line. It will provide us with prompts during the modeling process and keep a record of our actions. At the bottom is the status bar, which contains several tools that can improve our modeling efficiency. We'll cover those in more detail later. Additionally, these toolbars are all movable. We usually only adjust the viewports to make it easier to observe the model. Alternatively, you could drag out a separate set of tools that you need for modeling. However, some functions can be tricky to restore if you move them around too much. So, I recommend that you keep other areas in their default state, at least for now. Next, we're going to start building our first model. Let's first talk about how to use the mouse in Rhino. In Rhino's 2D views, the right mouse button is used for panning the view. You can hold down the right mouse button and drag to move the view around. In the 3D view, the right mouse button is used for rotating the view. To pan the view in 3D, you need to press Shift plus the right mouse button. The left mouse button is used to select objects. If you try to move something after selecting it, the object will move along with the cursor, but it can be quite difficult to control. The mouse wheel is used to zoom in and out of the view. Next, let's go over the display modes. First, when you click on a viewport, that particular viewport will expand to fill the entire screen area. By clicking on the small triangle next to it, you can open up the view panel. There are many tools in this panel, but we won't need most of them. The most important part is the set of display modes available here. Now, I'll show you the effects of opening the same model in different display modes. You can take a quick look at these examples. Wireframe mode, shaded mode, rendered mode, ghosted mode, X-ray mode, technical mode, artistic mode, pen mode, monochrome mode, Arctic mode, Ray Trace Mode. The display modes in Rhino can all be customized and adjusted. I'll provide a detailed explanation in the following sessions. Let's start drawing our curve. Here, we'll use the control point curve command to create a curve using control points, similar to how you would use the pen tool in Photoshop. Why can we draw curves with points? This is based on the NURBS modeling principle. You can pause and take a look at this diagram to understand the principle behind it. In fact, the two most common modeling logics in popular modeling software are 1. NURBS modeling, which we just introduced. 2. Mesh modeling, which is the logic used in SketchUp, SU, and 3ds Max. This involves creating models by combining countless triangles or quadrilaterals. For example, these two spheres in Rhino illustrate the difference. If you're curious about the specific characteristics and future prospects of each, feel free to ask AI. I won't go into detail here. Rhino can handle both NURBS and mesh modeling, but we generally focus on NURBS modeling. Alright, let's dive into the construction plane axes. These axes are like the compass for each viewport. They give us a clear sense of direction and help us model with precision. The three colored arrows represent the X, Y, and Z directions. In Rhino, the red arrow is the X-axis, the green arrow is the Y-axis, and the blue arrow is the Z-axis. If you click on one of these arrows, you can type in the exact direction you want to move. The three curved lines show the directions for rotation. And just like with movement, you can type in a specific angle to rotate an object. For example, you can say, rotate this object 45 degrees around the Z-axis. Now, here's a cool feature, the little square. When you change your view, you'll see three different colored squares pop up. These squares correspond to the other three 2D views. If you click and drag one of these squares, you can move objects on that specific plane. It's like you're working in the other 2D views, but all within the 3D viewport. For example, if you drag the red square, you're moving the object in the XY plane, just like you would in the top view. Next, we can adjust the curve we just created. Click on the curve with the left mouse button to select it. The corresponding control points will automatically appear. To move a control point, select it and press M on your keyboard. Then press Enter to confirm. This will allow you to move the control point. Of course, you can also move the control point using the construction plane axis. The Move command tool is located here. Just click on it to use the command. However, we usually prefer to use keyboard shortcuts for efficiency. Whether you choose to click on tools with your mouse or use keyboard shortcuts is really up to your personal preference. Use whatever method feels most convenient for you. Finally, you can see that there's a small dot of the same color on each axis. If you click and drag it while holding down the Shift key, you will notice that the curve becomes a surface. Similarly, by clicking and dragging while holding Shift, a point can be turned into a curve into a surface, and a surface into a solid object. When you select a solid object, you will notice that the little dot disappears. This is because Rhino cannot extrude a solid object further. Like the other parts of the construction plane, this little dot also allows you to input specific values for precise extrusion distances. For example, if you enter a value of 20, the surface will gain a thickness of 20 units. This command will be very helpful for our future modeling work. Next, let's continue to adjust the curve according to our own ideas. If you hold down the Alt key while moving, you can duplicate the selected object and then move the copy. This is a convenient way to create multiple instances of an object quickly. If you press F8 or click on the Ortho button at the bottom, you will enter Ortho mode. In this mode, objects can only move along the current X, Y, or Z axis defined by the system. This is very similar to how CAD software works, ensuring precise alignment and movement along the coordinate axis. Similarly, when drawing objects in ortho mode, you can only draw horizontally or vertically. This helps maintain clean and accurate geometry, especially when creating precise shapes or aligning objects in a grid-like fashion. In addition to these methods, you can also use Shift plus left mouse button to make multiple selections. This allows you to select several objects at once and move them together. To deselect an object, you can use Control plus left mouse button. This is useful when you want to remove a specific object from your current selection. If you want to select a range of objects at once, You can simply drag a selection box at the left mouse button. All objects within the box will be selected. If you drag the selection box from the top left to the bottom right, only objects that are completely inside the selection box will be selected. If you drag the selection box in the opposite direction, any object that has even a small part inside the box will be selected. This behavior is very similar to how selection works in CAD software. To clear your selection, just click in an empty area of the viewport. Before we start modeling, let's do one last preparation, setting the modeling units. Go to the menu bar and click on Tools. At the bottom of the drop-down menu, you'll find the options. Click on it to open the settings. In the Units section, you can set the model units and tolerances. Common units for architecture are millimeters, mm, and meters, m. You can choose based on your preference. I usually set mine to meters. After you've made your selection, click OK. You'll be prompted with two choices. Set them according to your needs. Finally, remember to press Ctrl+A to select all objects, and then click the Zoom selected command. This will allow you to see all the objects within the viewport after zooming. In fact, setting the units is one of the most important steps in modeling. As for the basic operations like I won't go through each one step by step. These are pretty standard shortcuts that you'll get used to quickly. All right, let's break down the modeling approach for today. The core tool we're focusing on is called Tween Curves. This tool creates any number of curves between two given curves. The shapes of these curves transition smoothly from the starting curve to the ending curve. This command is frequently used in architectural envelope modeling to create complex graduated forms. Of course, to complete the entire model, we'll need to combine this tool with various other functions. We'll delve into those in future lessons. Today's example is an indoor landscape feature. Here's a step-by-step breakdown of how we can model it. By following these steps, you can create a detailed model of a landscape feature. This process demonstrates how to use Rhino's tools to build complex forms from simple curves. And it's a great way to practice both basic and advanced modeling techniques. All right, let's start from scratch and begin today's modeling example. First, we'll drag out all the commands we'll need for this session. We'll start by placing 2-point objects as references to control the overall size of the model. Select the Point tool. You can place points directly in the viewport or input their coordinates. When entering coordinates, use a comma in English input mode to separate the values. Confirm it. This way, we'll place a point object at the 6-meter mark along the x-axis, setting the width of our landscape installation to 6 meters. Next, we'll draw a curve with 6 control points. Use ortho mode to ensure that the points are all at the same height. After drawing the curve, copy it 4 times with a spacing of 1.5 meters. Hold down the Alt key and click on the construction plane axis to align the copies. This will set the overall scale of the model to 6 meters by 6 meters. Next, we'll adjust the shape of each curve by moving their control points individually. Let's start with the first curve. Select one of its control points and lift it to a certain height. Do the same for the other control points to shape the curve as desired. Then, repeat this process for each of the other curves to achieve the look we want. Next, we'll use the tween between 2 curves that we just introduced. Select the first curve and the second curve, and then use the tween between 2 curves command. In Rhino, every command has many options, which will appear in the command line. For this tween between 2 curves command, the most important option is the number of curves to create between the selected curves. The current number is 10, but we can set it to 5 and press Enter to confirm. A preview will appear in the viewport. If the preview doesn't look quite right, we can change it back to 10 and see if that looks better. I think this looks good, but you can adjust it based on your own preferences, in addition to the number of curves. Another important option is flip. You can click on one of the curve endpoints to reverse the direction. You can also press the shortcut key F, but I usually prefer to click on the curve endpoint. or adjust it directly in the command line. One thing to note is that when using the tween between two curves command, Rhino will automatically align the nearest endpoints of the two curves based on where you click. For example, if we select these two endpoints, it might not look right, and we'll need to use flip to fix it. Next, we need to convert the curves into solid objects. First, use the construction plane axis to extrude the curves into surfaces. Select the curve and then extrude it along the green axis by 0.12 meters. This will create a gap between the surfaces. Let's check the effect in ghosted mode. We'll delete the original curves to avoid any interference with subsequent operations. Then, select all the surfaces and extrude them to add thickness. Here, we'll set the thickness to 0.04 meters. With this, the main body of today's model is complete. Finally, we can add some additional elements to enhance the scene and make it more complete. You can use Ctrl+C to copy a model from another file, and Ctrl+V to paste it into the current model file. This is a convenient way to bring in elements from other projects into your current work. Finally, we can use the turntable command to rotate the model. This will give us a nice 360-degree view of our creation. The number you input for the turntable command represents the percentage of rotation per second. Positive numbers will make the object rotate counterclockwise. Negative numbers will make the object rotate clockwise. It's a great way to see all sides of the model and really appreciate the work you've done. This is your first Rhino model. Congratulations. All right, with that, we've wrapped up today's modeling example. By completing this, you've officially taken your first steps into Rhino. You're now equipped to handle basic modeling tasks, and you might even find that you no longer need to rely on SketchUp, SU, for your projects. For this lesson's assignment, I want you to put into practice what we've learned so far. Create a model of a landscape feature and set up a Rhino scene. Dive in and get some practice. I'm Architect Smith. Thank you all for joining me today, and I hope you found this session helpful. Be sure to like and subscribe for more content. I'll see you in the next video.